Hello students, welcome to Module 6. The learning in this module is to transfer away from raw pointers to using shared pointers. As you know, raw pointers can sometimes be very dangerous territory, and shared pointers do the pointer management for us, because the issues with raw pointers was we could have things like dangling pointer problem, memory leaks, and all of that stuff. In order to manage pointers in a safe way, what C++ does, it permits a pointer management system, and that essentially is called shared pointers. Of course, when we add in safety, we tend to lose a little bit of the speed and slickness that we used to have with raw pointers. And what we lose is we lose pointer arithmetic. We'll also lose the fact that shared pointers with arrays doesn't work too well. So that's why we are going to transition out of arrays of pointers that we were doing to vectors of pointers. So the key learning in Module 6 lab is for us to create a pointer to a circle object and to create a vector of pointers. So what I would like to do in this demonstration is to go to our demonstration, our demo class, which is our point class, and see how we can create a pointer to a point, compare using the greater than, that's your requirement in the lab, and also to create a vector of pointers. I will not be doing all of the methods that you need to do in the lab, like area, which is a simple calculation, but the greater than method is important because it's an extension of some of the things we were doing with the equals method, in that it was comparing two objects and to see if they were equal. In this case, we are comparing two points to see if one is greater than the other. Of course, with circles, we said we could easily say one circle is bigger than the other if the radius of one circle is bigger than the radius of another circle. But with the point, I'm just going to define it and saying one point is greater than another point if the x of this point is greater than the x of the other point, and the y of this point is going to be greater than the y of the other point. So that's going to be our greater than definition. So let's get started with taking a look at our header file. And as we can see, our point file is kind of remaining the same. The default constructor is right here. The regular constructor is here as before. And I'm now introducing a greater than method. And as you can see, what's coming in is a pointer to a point. Other is not just a pointer, but it's a pointer to a point, and the type of pointer is shared pointer. It's not, it used to be, before we were doing something like point star other, and this is now exactly equal to shared pointer, and then we put the point here and we say other. There's one additional step that we need to do with shared pointers, is that we actually need to construct them, right? So here, for example, when we were doing, I'm going to move this thing here, when we were doing declaring a pointer called other, to a point, we also wanted to, if we wanted to create pointed to an area in the dynamic memory with what was the heap, you would say is equal to new point, and then we would pass the constructor, I don't know if it was 3, 4, for example. This not just declares the pointer, but also constructs the point object and sets other to point to this dynamic area in the memory, right? The equivalent of this is shared pointer other equals make shared and here we would do this, right? So here these are the two equivalent statements where we declare a pointer and we construct it, declare a raw pointer, construct it, declare a smart pointer or shared pointer and construct it. Right? So now I'm going to delete this because this was just for explanation purposes. And as you can see, I have created a parameter which is a shared pointer to a point. Now let's go inside. Just before we move away, I'd like to point to all of these tons of libraries that we have here. They're pretty much the same libraries as we were using. The one that really stands out here is memory. And every time you need to access the dynamic memory and shared pointers and stuff, then it is a good idea to include memory. Otherwise, you might run into some very strange kind of issues. Now let's go into the implementation file and go into all the other methods. The constructors and all of that are the same. The greater than method, what happens here with the greater than method is what I'm doing here is I'm saying if this x is greater than others x, and as you can see I'm doing other arrow because other is a pointer, right, to a point. So rather than saying star other dot get x, like dereference it and then access the field, the arrow does the dereferencing and accessing the getX method of the point. So if x is greater than others x and y is greater than others y, then you return true. That's what this greater than method is doing. And now let's go here to the main point of the story. This input data is a very familiar method to you for opening a file and populating the database. It turns out that the database here is a vector of shared pointers. As you can see, there are lots of angle brackets here. So a vector, and the type of the vector is vector of shared pointers. So the angle bracket for the type, and then the angle bracket again for the pointer to a point, and closing the two double. And then because it's a vector, we pass it by reference, and that's why I've called it a pointer array. And then here what we're doing here when we populate the database is read the x, read the y, which is, if you go into the data file, it's just got 4 elements, 1, 2, 3, 4. This is the first one is the x, the second one is the y. And what it does is it reads the line, it gets the line by line, passes it to to the iString stream, and extracts the x and y, and then uses that x and y to create a pointer to a point. So this statement here creates this point is a pointer to a point object with the x and y that you just read from the file, right? And you're putting this into the pointer array. So what's going to go into this pointer array is not the point, but a shared pointer to the point, right? All right. Now let's come to main, and here what we are doing is we are creating 2 pointers. The first one, now this is before we populate our vectors, right? This is just like a sample to help you with the lab. So here what's happening is I'm creating the first pointer called point1 pointer, and what point1 pointer is doing is it is point1 pointer is a pointer to a point which has got the coordinate 0, 0, and point2 pointer is a pointer to a point that is at position 3, 4. And then I'm comparing point1 pointer to point2 pointers, and what's actually getting compared is the x of this is getting compared to the x of this, and the y of this is getting compared to the y of this. Since point2 pointer has got x greater than the point1 pointer's x, and this y is greater than that y, what it should say is that, clearly it says point2 is the bigger one, and it should say point2 is bigger. When we run this program, this is what we should expect to see. Then we come to this business of actually populating the database right here, right? So we're populating the database by calling input data and populating from the data file. And then the total number of points is, it should say 4 because there were 4. And then what this is doing, it's just printing all the 4 point objects. Now here we are not doing the sum of the areas, right? That is something that you will do in the lab and write the areas method So I'm going to mute this, right? So all I'm going to do is I'm going to print the vector, then this business of swapping, right? The third learning that you were doing was the advantage of using pointers is that you don't need to do heavy lifting by moving objects, but you can just swap pointers, and pointers are always of the same size regardless of how heavy the actual object is. The object could be a database, and if there were 10 huge large files and you wanted to switch the position, then you are moving gigabytes of data from one place to the other. Whereas if you're moving pointers, then a pointer is usually 4 bytes of data, right? Because it contains a memory address. So moving 4 bytes is nothing when you compare to moving gigabytes of data. So that's a learning you're doing here by swapping. And as you know, when you swap, you need to have a temporary variable. So I would like to swap the second and the fourth vector. So that's why 1 and 3, because this is, so 1 is actually the second, 0 is the index 0 stands for the first, 1 stands for the second. So I'm swapping 1 with 3, which means the second with the fourth vector, second with the fourth point object. And I'm doing that by actually switching the pointer to these objects. I'm saving that, I'm saving the pointer in a temporary variable, creating a temporary pointer, saving the pointer at position 1, at index 1 in temp pointer, transferring or copying over the address contained in index 3 to index 1, and then because I had saved what was the contents of 1 before it got overwritten in 3, now what I can do is now I need to move what was originally in 1 into 3, and that's what I'm doing by moving temp pointer into 3. And now I'm printing the modified array. So I'm just going to run this program right here and see that the tasks that I've gotten accomplished are: number 1, I've created those two pointers, circle pointer 1 and 2, compared them, so 2 should be bigger, print out the vector array, and then show what happens to the modified array after we do the swap, right? So let me run my replit right here. And here we go. It says point 2 is bigger, the total number of points is 4, and here are the points. And then after I switch 1 with 3, which is index 1 with index 3, then -9, -3 should go here, and 0 should come at the bottom, and that is exactly what has happened, right? Thank you.